Right. So we were looking at sort of basic networking theory yesterday. Let me just actually put this here. It might be easier. We're looking at basic networking theory yesterday, and we were seeing. So what did we went through? We went through the OSI model. We looked at your 7 layers: application, presentation, session, transport, network, data link, and physical. We looked at TCP versus UDP, which is part of the transport layer. I want to kind of go back over one or two things, but first I want to look at the concept of the default gateway. Okay, so yesterday we looked at the subnet mask. Want to open up, I'm going to just open a packet tracer here, right, and have a look at what's known as the default gateway. So I'm going to get a laptop here. I have another laptop here, and I'm going to get a switch here. Okay, so all these are going to be in the same network. Okay, so we've got 2 laptops and a switch, right? Does this work? Remember yesterday it didn't work. 192.168.1.2. Ah, okay, there you go. Works now. And listen, 192.
Sorry, is it just me, or are you sharing your screen? Oh, sorry, yeah. No, it was actually my fault. Sorry. It had pinned something else.
Okay, that's okay now. Is everybody? You should be able to see packet tracer now and a couple of files on the screen. Yeah.
Yeah.
Okay, great. Yep. Yeah, brilliant. All right. So we've got 2 laptops there. 192.168.1.2, 192.168.1.3. I'm going to connect them together. Connect into fast Ethernet 0. And again, here, when with the switch, it doesn't matter what port you connect into. Switch doesn't care. Next Tuesday, I will be talking about how switches switch. So we'll go through it in this much. We will go through this in much more in depth. So let's say we put 2 into 0/2. It doesn't have to be. We just keep things nice and simple. And we put 3, 192.168.1.3 into 0/3. Okay. You see it's going green there. You see the switch ports are going orange. Now I'm going to get a router here. Just use one of these guys. 1941 here. Okay. So this router here is a connection to another network. Okay. A connection to a different network. So here, I have a connection here, and we just use 0/1, and we connect that to the gigabit 0/0. Okay, so you can see the physical links, the physical ports. So the physical port FA stands for fast Ethernet. Fast Ethernet speeds are 100 megabits per second. So FA 0/1 on the switch is connected to gig 0/0 on the router. FA 0/2 is connected to 192.168.1.2. Let's just call him Al. 192.168.1.3. Joe. Okay, Al and Joe. Yeah. Make it a little bit bigger. What's the command to make it bigger? There we go. Okay, cool. Now, the default gateway, the concept of the default gateway is the IP address that you need to know in order to reach a different network. So let's say I'm going to bring this cloud up here. I'm just using this cloud as just for graphic purposes. Okay, this is just our connection to the internet. Okay, and here we're going to have a link going from the cloud, create a new link to here. Yeah, so this is our ISP. Let's say this is our link to Skype. Internet. Okay. Any questions on that with that setup? How many different networks do we have here?
2.
2, yeah, 2. Remember, every connection on a switch is a member of the same network. Every connection on a router is a member of a different network. That's the way to remember. Remember, yesterday I was saying switches provide communication. You know, switches provide communication between devices within the same network, and routers are different networks. It was the one I actually said. This is the one thing I wanted to remember from the class yesterday. So basically, here, let's say here, I'm gonna fill in color. I don't know if this works. Select fill color. Here, yeah, there we go. Work? No. Why now it works? All right. We try that. There we go. So that's one network there. Yeah. And the other network. Select for the color. Yeah, green. Oh, there we go. I'll just leave it like that. That work. Sorry, packet tracer is not so you can see two networks here anyway, so I'll just leave that one. Delete. Okay, let's try this one. No, that's the wrong one again. Try this one. There we go. Okay, there's two networks, if you like, just for illustration purposes. Yeah, so you got two connections on the router, gig 0/0, which is the link to the Dublin LAN, and then gig 0/1, which is the connection from our router to our ISP. By the way, this link here, this line we have here, if I can put in a line here, put in a line here. I'm trying to. It's sort of was what's known as a line of demarcation, because basically anything that happens here is our issue as such, is our company issue. Yeah. So if any of these links go down, including gig 0/1 on the router, then we have to sort it out. We have to fix it. But if this connection here to Sky goes down, well, then we can't do anything about that. That becomes a problem with the ISP, that they have to look into that. Anything here on the left, using the red circle, we have to fix it. It's our problem. Anything sort of in the green here, except the fiber optic connections, the SFTP or the QSFP into the router here will be part of Sky. Any questions on that?
No.
Okay. So where the default gateway comes in, I'm just going to delete this here because it's just getting a bit messy. Where the default gateway comes in is that I'm going to go in here into the PCs. Al's IP address going to the desktops, I'm going to say is 192.168.1.2, and the subnet mask is 255.255.255.0. Yeah. The default gateway, usually the default gateway is the very first host in the network. Okay. And I know this network here is 192.168.1 network. Why? Because the subnet mask tells us so. So the very first host is going to be 192.168.1.1. Go down here, 192 Joe, his IP address is 192.168.1.3, default gateway 192.168.1.1. So I will assign this router here gig 0/0. I'll do this real quick. Don't worry about the commands yet. Okay, so I'm after giving this router here the interface. You will be doing this next week. or the week after, 192.168.1.1 has been assigned to gig 0/0. Okay, so this address is 192.168.1.1. So in other words, if Al here wants to go to talk to Joe, source IP address 192.168.1.2, destination IP address 192.168.1.3. Yeah. The traffic is going to go, the packet is going to go into FA. It's going to leave Al's PC on his on using his the NIC on his PC. It's going to go into the switch on physical port FA0/2 because that's Al's PC is connected to physical port FA0/2. The switch is going to process it and it's going to send it out to 192.168.1.3. Yeah. Now, if we're going across to 8.8.8.8, what's going to happen? Let's say 8.8.8.8 is Google. 8.8.8.8. It's over here, and the packet is going to go across here, over into gig 0/0, and it's going to go over here. Is that okay? Is there any questions on that? Because Al needs to know that Al's PC will know that 192.168.1.2 is on a different subnet to 8.8.8.0. These are on different networks. So therefore, this needs to go to our default gateway. Okay. Let me open up a slide here. All right. Okay. Let's say we have actually what I can do here is this. Give me a second. I want to delete some of this here. So this is, let's say this is our Dublin LAN, yeah, over here. Dublin LAN is here, and I'm going to have another connection here. Let me just put in another router over here. And this is going to be London. Okay, so connection here to here, and then we're going to have another switch over here. So this will be our London LAN. We've got a PC over here. Yeah, it doesn't matter what type of connection going in. Okay. Now I'm going to put in MAC addresses. Okay, what I want to do, I'm going to, it's getting very confusing. So I want to remove the physical links. Yeah, that's better. Okay. So I'm going to put in MAC addresses here. So this is one and by the way, I'm just trying to tidy things up here. So one, just using shortcuts here, okay? 1.1, if you think about it, this is the 192.168.1.0 network. This is Dublin. Guys, at any time, let me know if you have a question. Sorry, I'm going to try and keep chat open here. Anytime use chat or take yourself off mute and ask me any questions. So this is the Dublin network. We're going to give, this is the 192.168.1.0 network. Okay. Now, first of all, how many different networks do I have as per this diagram?
4.
Just looking at this diagram on its own.
1. 3.
3. Yeah, we got 3 networks. We got the link here 192.168.1.0 network, which is this guy here. And this is the Dublin router. I'll just say this is Dublin. This one here is going to be London. And then we have a Dublin LAN over here. Yeah, okay. So we'll just give this a different subnet, 192.168.2.0, which is the link, the network here between Dublin and London. That's a different network. We said every router on an interface is a member of a separate network. So this network here, 192.168.2.0, is shared between Dublin and London. Okay. London over here, the London LAN, we'll give it 192.168.3.0. Okay. Now this is going to have 1.1. Let's say this is 2.1. This is 2.2. Okay, so 2.2 and 2.1 here isn't 2.1, it's IP. The full IP address obviously is 192.168.2.1. The full IP here is 192.168.2.2. Okay. London, we're going to give this 3.1, which is the default gateway here. And we give this guy here 3.2. Okay, this is Tom over here. What's Tom's default gateway address? What's Tom's laptop's default gateway?
192.168.3.1.
Yeah, that's it. Yeah, exactly. So if Tom wants to reach a different network, he has to send it across to the default gateway. Al and Joe's default gateway, actually everybody in the Dublin LAN, their default gateway is 192.168.1.1, because that is their local IP address of the router that they are connected to. You don't really have such a default gateway here between Dublin and London because it's a point-to-point connection. The default gateway that you have over here in the London, sorry, where we go? Where did that go? In the London network, if we had, let's say if we had 200 people in the London office, their shared default gateway address would be 192.168.3.1. Okay, any questions on that?
Is there any reason the London gateway wouldn't have the exact same IP address as the Dublin one if they just got set up and happened to be interconnected later on?
Yes, very bad design. You wouldn't do it.
All right.
Because I'll tell you why. Let's say you had, it's a very good question. Let's say you had Belfast here, right? And you had a network here in Belfast. Just see. Okay, so this is you had a network. I just put in a PC here. Okay, this is a LAN in Belfast, right? And this network here in Belfast is 192.168.5.1. All right, let's say this IP address is 5.2. Okay. And your question is just so I'm not going to put in a switch because it's kind of complicate things. Well, let's connect this into the router here, okay? But let's say there was a switch here, right? And this is Belfast. So let's say this London was using the same subnet as Dublin, yeah? So let's say this was 192.168.1.0, and this is 1.1, and this was 1.2, yeah? Okay, and Belfast had a connection going to Dublin. It's not going to work. Okay, let me just do it 1 second. I can annotate this. Let me draw this on. Belfast had a connection going to Dublin, and Belfast had a connection going to London, right? And this guy over here, this is James. James wanted to ping Al. Okay, he wants to send a ping to Al, right? So his source IP address is, so he's sending a ping. Source IP address of James is 192.165.2. Destination IP address is going to be 192.168.1.2. What's going to happen? Packet's going to go into Belfast. Belfast is going to go, oh, okay. Now remember, Belfast will know about this network being over here as being 192.168.1.0, and we'll know about this one over here as being 192.168. Now Belfast goes, oh, something's wrong here because I have a network over here 192.168.1.0, and I have another network over here 192.168.1.0. So what will happen is Belfast will send half the packets this way, and the other half will go this way, low balance. So basically, half the packets will go to Al, and the other half packets will go to Tom. So when you do your subnetting design in your company, every subnet should be unique within that company.
I was going to say, I can imagine the issue arising when two companies merged and they just happen to have the same thing, and then
absolutely, there's you have a lot of problems with that. You have to re-IP your whatever company is the smallest one, or actually not even the smallest one, whatever company is the one that was taken over usually. Yeah, and there's a lot of problems. Yeah, we're going into kind of CCNP territory where you have to use what's known as route redistribution, and you got different routing protocols that will conflict and stuff like that. Yeah, but yeah, there's definitely issues with that if you have, because like 192, every company has your 192.168 in it, you know. So yeah, I had that issue as well. I had it when years ago when I was working. We had to Quinn Insurance got taken over by Liberty Mutual Insurance, and we had re-IP all our Quinn infrastructure, so it wasn't conflicting with Liberty Mutual's infrastructure. So yeah, bit of a pain, but yeah, you can see why. So every network here should be in the company should have unique IP subnets. Okay, so question. Let me just clear that there. Okay, and close that. Right. I just want to close this here. I'm not gonna use Belfast in this network here. Okay, cool. Now let me just give me a second here on this. I want to do some screenshots here. There we go. Okay, cool. I just want to copy this and open a paste and paint that in. Okay, cool. All right. So there we have the network. I'm just using Paint because I'm using Paint because it's easier. And I'm also going to assign MAC addresses. Okay. So the MAC address I'm going to put in red. Okay. So Al's MAC address here is going to be A. 1 second. A, and this MAC address here is going to be B. This MAC address here is C. This one here is D. This one here is E. This one here, I'm just going to have 1111. This MAC address here of Tom is 2222. Now, by the way, MAC addresses are 12 hexadecimal characters. Okay, so the format is wrong, but it's just going to be bloody MAC addresses all over the place. So just ignore the format. Next week, I'm going to talk about MAC addresses and the right structure. But just assume that here AAAA is 12 A's, 12 B's, 12 C's, 12 D's, 12 E's, 12 1s, 12 2s. Okay. I'm just trying to keep things neat. I'm not really good at keeping things neat. Okay, so let's say Al here wants to talk to Joe. All right, so you have source IP 192.168.1.2, destination IP 192.168.1.3, source MAC. Actually, put this in black. Source MAC could be in red. AAAA. Destination MAC is going to be B. Any questions on that? Okay, so there's your so again, remember your three layers of your OSI model. One second. Sorry guys, 1 sec. Trying to do something here. There we go. Okay. So you got your network layer, which is responsible for your IP address, your data link layer, which is responsible for your MAC address, and then you got your physical layer, which is your ones and zeros. Okay, so you got your network layer, and the network part of the information is in black font, right? I have a line here just separating the two. The MAC address information is in red font. So this, what's going to happen here, and then you're going to have a separate piece of information then for the actual data. Which we here. So this here, this is your details. So just look at it from an address point of view. So you got your source IP address 192.168.1.2, which is Al. Destination IP address, which is Joe 192.168.1.3. Al's PC AAAA. Joe's MAC address is BBBB. So what will happen is this frame is going to leave Al's, it's going to go into the switch. The switch won't even look at the black font. Switches are layer 2 devices. The switch only looks at the red font here. While the router will read the black font. Routers make their forwarding decisions based on the IP address. Switches make their forwarding decisions based on the MAC address. Any questions on that? Okay. So the switch will look and go, oh, you're going to BBBB. Next week, I'm going to actually talk about how the switch switches. Just assume that the switch knows that BBBB is connected to this physical port, and it'll say, okay, you're BBBB, and BBBB is port 2, and I'm going to send it out here, and Joe gets it. All right? Easy peasy. All right. The next thing, Al here wants to talk to Tom. So we have to remove some information here. Okay, source IP address is 192.168.1.2. Perfect. That's not going to change because Al's IP address is 192.168.1.2. Destination IP address is going to be 192.168.1.2. Oh, sorry, this was the old. Remember, Tom's IP address was 3.2. I had changed it earlier on.
Sorry, yeah, that's it.
Yeah, I'm going to change that back now in a second. So 192.168.3.2. Remember, I only changed it to illustrate London. This is not the right network. This is going to be 192.168.3.2. And this was 3.1, and this is 3.2. Let me just put that in here. So this here was 3.1. Maybe a bit bigger, 18. Yeah. And the other one was 3.2. Tom's IP was 3.2. Yeah. And it's 3.2. Why does that do that? So Tom's here is 3.2. Okay, so source IP address 192.168.1.2, destination IP address, which is Tom's PC, 192.168.3.2. Source MAC address, which is AAAA, yeah, which is Al's laptop MAC address, yeah. Destination MAC address.
2.2.2.2. No. 1.1.1.1.1.
1.1.1.1. Anyone else? I'm going, Sergio. The destination MAC address, Richie, will be CCCC.
Okay.
Which is the default gateway address of the Dublin router. CCCC. It's going to be in red. Destination MAC address is CCCC. We have different devices do different things. Switches provide communication between devices in the same network. Routers provide communication between devices in different networks, okay? In order for Al to be able to talk to Tom, Al is in Dublin, Tom is in London. What has to happen? This information has to go to the router. But we don't, if we don't have any address, if we just had IP information here, we have Tom's IP address 192.168.3.2. That's no good for our local network. Like, let's put it this way. Let's say Al here lives in Lucan, right? He lives in Lucan. And he's visiting his friend Tom, and his friend Tom lives in Vauxhall in London. Okay, London. Yeah. Al can't just disappear. He can't teleport from Lucan over to Vauxhall. He needs to go. If he wants to visit his friend Tom, he has to get a flight. So what does he have to do? He has 2 trips, doesn't he? Well, he's a number of different trips. His first trip Al has to make is he needs to go from Lucan to the airport. To the airport. Because he can't go he can't get to Vauxhall unless he first goes to the airport, Dublin Airport. So as Al is driving from Lucan to Dublin Airport, he has two addresses in his head. One address is Vauxhall. He's visiting his mate Tom, who lives in Vauxhall in London, which is the overall destination address. But the more immediate address is his local address, is his local journey from Lucan to Dublin Airport. Because he can't get to his final destination, which is Vauxhall, unless he first goes to Dublin Airport. Okay, does that make sense? So Al is driving, he goes into Dublin Airport. That journey, he parks up his car in the short-term car park or whatever. That journey is finished. Then he has to go from Dublin Airport to Heathrow. That's another journey. He's more like, so he's in Dublin Airport, he has to get the flight from Dublin Airport to Heathrow. And again, there's still two journeys in his head. There's his immediate journey, which is Heathrow Airport, and his final destination, which is Vauxhall. So he goes across and he lands in Heathrow, and then he just needs to get the taxi from London to Vauxhall. Which, if you look at this case, if he's in London Airport, he's in Heathrow, we've only got one journey then, because it's the same journey from London Heathrow to Vauxhall. His final destination is his local destination. Yeah, and Pablo, it's the same process in reverse. Okay. So that's why you have two addresses. That's why you have a router and why you have an IP address and you have a MAC address. The MAC address defines your local destination. Okay. So let's look at this packet, because at the end of the day, okay, we have a switch here in Dublin. This is our Dublin switch. This Dublin switch doesn't give a damn about anything else outside of its own network. The Dublin switch only cares about the Dublin traffic. Because what did I say yesterday? I said switches provide communication between devices in the same network. If a switch only cares about communication in the same network, it doesn't need to know about over here in the 2.0 network or over here in the 3.0. The Dublin switch says, I don't care about them. I only care about my local traffic. All right. So what happens? Putting all this information in, goes across into the router, into the switch. The switch goes, oh, you're going to CCCC. I'm going to send it out this port. So it's the MAC address here, the red font, that the switch will use to send it to the default gateway. Okay. Now what will happen here? The Dublin router will look at the black font. So we're in Dublin router and it'll say, oh, you're going to 3.2. Now I will spend hours talking about how routers route. Don't worry about that. Just assume that this Dublin router has a fully populated routing table and it says, I know how to get to 192.168.3.2. Now what's going to happen? What do you think happens? If you think about it, this information containing the MAC address information, AAAA and CCCC, are now irrelevant because they belonged to this network over here. We're no longer in this network. We're moving across into a different local network. So what the Dublin router will need to do is it will need to strip off the source MAC address and the destination MAC address and put in a new source MAC address, which defines this local hop between the Dublin router and the London router. So the new source MAC address is going to be DDDD. That red font. The destination MAC address is going to be EEEE. So this packet now is going across the local network between Dublin and London. This is a separate network. So we need to have the MAC addresses for each specific network. Okay, so think about it. MAC addresses define your local destination. While the IP addresses define your global destination. Any questions on that?
So in the Dublin router, could those two switch ports have the same MAC address?
Which ports here?
So CCCC and DD. I know they're two different MAC addresses clearly labeled there, but
so the one here,
could the
so
NIC
this,
be the one and just have two different ports on it?
well, so
Or
CCC here on Dublin is, so 1.1 on Dublin is CCCC, yeah?
Yeah.
And 2.1 in Dublin is DDDD.
Yeah.
They do have separate MAC addresses.
I know they do, but I'm just wondering, is it is it technically possible for it to be the same MAC address?
No.
So each port would have its own MAC address?
Yes, and it's a great
Okay.
question. Every port has a separate MAC address because MAC addresses define your local network.
Oh, yeah.
So this is one network over here and CCCC, and this is a different network. So yeah, they have to be different. They have to be different. You know, earlier on, someone asked a question about what if you know, can you have two IP addresses? I say no, and this is the same reason. You know, if you live in a street and in an estate and it's Willow Green and your house is 4 Willow Green, there's not another house down the road in Willow Green called 4 Willow Green either, using the same postcode, because it's going to confuse the postman. It's the same concept. Okay, so what's going to happen is this is going to go across to London. Why? Because there could be a switch here between Dublin and London, and the switch will need to know that information to send it over here. So this packet here reaches London. It's going to come in on 2.2. What's going to happen? The London router is going to look at the destination IP address 192.168.3.2, and it's going to say, I know about that network. I know about the 3.2 network because I'm obviously connected to it. London is connected to the 2.0 network, and it's also connected to the 3.0 network. So London says, I need to send this packet out interface 3.1. But what do I do?
Strip out the source and destination.
Strip out the source MAC address, strip out the destination MAC address. The new source MAC address becomes
11111.
1111. Yeah. And the new destination MAC address becomes
All the twos.
2222. Yeah, that's it. Because you think about it, this information is for the local London switch. We need to tell the local London switch that this information is going to Tom over here. So we need to have the MAC address of Tom's PC. The router needs to know the MAC address of Tom's PC in order to tell the switch that this is going over there.
And all these MAC addresses will be put in during the routing table, right?
No, the MAC addresses, this is where it gets confusing. The MAC addresses are built automatically by the switch. That's a completely different process. We'll look at that on Tuesday.
Okay.
And we look at that process. So I'm kind of skipping over that part now because it's just too confusing to talk about how a switch switches and all of this in the same kind of class. So you just have to assume that the switch knows that 2222 is connected to physical port number 2. So what will happen is this packet will leave the London router. It'll go into the switch. The switch then looks at the red font, the red MAC address, and go, oh, 2222. I know 2222. I know the MAC address. I know in order to reach the device that has a MAC address of 2222, I need to send it out physical port number 2, and it'll go across into Tom's PC. That's why we have 2 separate address concepts. We've the IP address, which defines where we're going globally. We've got the MAC address, which defines where we're going locally. If you notice something about the IP address never changed. Didn't change. Whilst the MAC address changed 3 times. Every network changes. The reason why it changes 3 times is because the MAC address defines your local networks. So you're going to have new MAC addresses every time it goes into a different network. The router's job is to take the old MAC addresses off and replace them with the MAC addresses of the new network that is going to be sending it out. So this goes into Tom, right? Then what does Tom need to do? Tom needs to send a response back. Okay. Source IP address. So the source IP address now is going to be 192.168. I'm just going to write it in, it's easier. 3.2. What's the destination IP address is going to be? Oh, sorry, 3.2. Destination IP address, that should be 3.1. Sorry, 3.2 even. Destination IP address is going to be 192.168.
1.2.
1.2. Yeah. Source MAC address is going to be
11111.
So we're looking at the packet from Tom back to Al. So the source MAC address is going to be 2222.
Sorry, and the destination is 11111.
So yeah, exactly. So source MAC address is going to be 2222. Destination MAC address is going to be 1111. And then the whole thing happens in reverse.
Reverse, yeah. Very good.
Very important. You will see it's always, not always, but I have seen lots of questions about this. They'll give you something like this, a network diagram, and you have to fill in the blanks and say what the source IP address is. It will give you enough information, but you need to know what, so basically it could give you this. It'll say this packet is a response packet from Tom back to Al. What will be the source MAC address and the destination MAC address when this packet enters this port here? So the source MAC address will be 2222. The destination MAC address will be 111. You have to fill it out. It'll be a good exam question. Because if you didn't know it, you'd probably say the source MAC address would be 2222 and the destination MAC address will be AAAA, but that's not right. Because the London switch here doesn't care about the MAC address of anything else over in a different network. The London switch only cares about local MAC addresses, 2222 and 1111. Tom can't visit Al if he can't reach his default gateway. I can't get to Lanzarote if I don't know my way from Blanchardstown to the Dublin airport. Do you know what I mean? Okay, any questions on that there, guys?
No, all good.
Okay, cool. Yeah, so looking at this, we had, I think that's really it now, just kind of, anything you want to talk about as from yesterday? So what do we look at? Let's just spend a minute and come back over the OSI model again, will we?
If you were Al, and if you wanted to, you know, you were talking about the subnet mask there. Obviously, you go 255, 255, 255.0, but then you go 255, 255.0.0 for both of them. So because they're on different networks. If you wanted to ping the different networks.
So well, you could use different subnet masks, you know.
Right.
So but you like, I mean, you could have 255, 255, 255.0 here.
Yeah.
And then you could have a completely different subnet mask here.
Right.
And a completely different subnet mask over here. That's fine. Because subnet masks define the size of the network. So the Dublin network could be big. The London network would be even bigger than Dublin. And like, I mean, this link here between Dublin and London isn't big because we've only got 2 connections.
Yeah.
And don't worry about subnetting. We'll
Yeah, of course.
What's that?
Okay.
Okay. Any questions, guys, on that? Any more? Okay. Right. Cool. So just really, yeah, that's it then. Guys, we'll just say, if you get a chance, you need to do homework. You know, I'd say for homework, go into your Dropbox. Do I have the? Let me a second here. Let me stop the recording. Keep the recording open for a second. So the homework is you want to go into Dropbox, okay, and go into that link I sent you, CCNA material. Don't worry about common commands or GNS. So I would say install Packet Tracer, play around with it, and you know, just do what I did there in the video even, and at the start. You know, give IP addresses, set up a couple of PCs in the same network. One, you know, set up a Dublin network and connect the PCs, a couple of PCs onto the switches, and just play around, get used to the feel of it. The instructions are there on it there, the link to install it. So basically you have to install it. You have to go to Cisco Net Academy to log in. You get it, you can sign in and you can get a free, sign in for a free course. You don't have to follow the course. Download Packet Tracer and click on sign up. There's the link there. So install Packet Tracer. The recorded classes are there. Go back over your slides, all the slides from yesterday, which we talked about there, and the tutorials. How to study Cisco, what is networking, introduction to the OSI model, TCP/IP, how to change an IP address, your stack, your IP, and your default gateway. Okay, guys. Any questions?
All good.
Okay, great. All right. All right, guys. Well, see you on Tuesday. Have a good weekend, and yeah, take care.
Cheers. Thanks. Thanks. Bye.
Thanks, guys. Thanks. Bye. Bye. Bye.